Okay, so today we're going to continue with functions. You'll see my recording messed up a little bit. So I started number one. We are going to do a warm up today before we jump in. And so yesterday we talked about function notation. And so this is written in function notation, function p of x. And it wanted us to evaluate when x is 7. So I substitute in 7 for x and evaluate that. And it gave me 9 for an output. And remember, we want to write our function notation. Our final answer should have the same notation where I can see I put in 7 and I got out 9. So now I'd like you to try the second function. So here's function f of n, and we want to evaluate that function when n is 8. So go ahead and do that work and we will compare in a moment. So what I have here is just the initial setup. So I've substituted 8 anywhere that there's an n in my function. Now, when I evaluate this, we need to remember PEMDAS, meaning I need to do this exponent before I do this multiplication. So I'm going to have f of 8 equals -2 times 64, and I can go ahead and do this multiplication, subtract 16. Okay, so make sure you followed PEMDAS there and did your exponent before your multiplication. And then I have my function when x is 8 is -128, subtract 16. And my function when n is 8 equals -144. And also make sure we wrote our final answer in this setup where we can see I put in 8, I get out -144. So yesterday we also talked about function form of a linear equation. So something isn't in function form. This is function notation. So this is written as a function notation. Linear equations are written with x and y, where x is my input and y is my output. And so when I have x, y, my linear equations, we many times want to rewrite those in what's called y equals mx plus b, slope-intercept form, or in this case, what's being referred to as function form, so that it's easy to plug in a value for x and get out a value for y. So function form of a linear equation means that y is isolated, okay, or that y is by itself, okay, where it's y equals whatever my equation is. So we're going to look at a few examples. So it says rewrite so that y is a function of x. Or if I were to write it in function notation, it'd be y of x. If I plug an x in, what do I get out for y? Okay. So here's my first equation. And if I want to isolate y, this is like literal equations from last unit. So if I want to get y by itself, first I would subtract 2x from both sides, and that would give me 7y equals -2x subtract 14. You could also write it as -14 subtract 2. So we subtract 2x, sorry, I had to pause my video for a minute. And now if I want to isolate y, we need to divide by 7. So what I'm going to ask you to do when you do this last step, because it's always going to kind of, for the most part, depending on how our equations are written, but many times it feels the same, where first we move x, then we divide or multiply by whatever is in front of y. Now when I do this, I'm going to break this apart and reduce if I can. So I have -2/7 x subtract 14/7 reduces to 2. Here's my equation. So same equation, but I've rewritten it in terms of y so that it's in function form, so that now I can plug in for x and easily get out my y value. Let's look at this again on 3. So if I want to isolate y, first I'll subtract x. That gives me -y equals -x subtract 1. It's super similar to when we were doing literal equations. Now I need to divide by -1. So be careful there because I need to divide everything by -1, which would make it +x and +1. And there's my equation rewritten in function form. Rewriting 5 in function form, I'd subtract x from both sides and have 5y equals -x plus 10. Then I need to divide by 5. Everything needs to get divided by 5. which gives me negative 1/5 x plus 10/5 is 2. Here's my equation rewritten in function form. On 11, I'd subtract x, and it would give me 7y equals negative 11x subtract 56. Divide by 7, and y equals negative 11/7 x subtract 8. Last one I'm going to do with you. So first, again, my whole goal is getting y by itself. So first I'll move the x term. Negative 8y equals negative 7x subtract 32. And then every term gets divided by negative 8. Being careful with my signs on this last one. So negative over a negative gives me a positive 7/8 x. Negative over a negative gives me a positive 4. So before I let you try some on your own, I'm going to go back up here. So it's all about getting y isolated. And so to do that, many times we want to do any addition subtraction moves. Our x term and any constant terms. So sometimes you have more than just your x term over there that you need to deal with. And then we were multiplying or dividing by the coefficient in front of y. Okay, so if you notice, I always kind of followed that procedure. First, I added or subtracted over. It's all about inverse operations, that x term. And then if it was a fraction, we'd maybe be multiplying, but then I dealt with the coefficient or the number in front of y. So I'm going to ask you to rewrite the even examples down here so that it's in y equals, so it's a function form of linear equation, and then continue the video and check to see how you did. Okay, so now looking at these odd numbered problems, I've just gone through and rewritten each of these equations in function form. So I move my x value, then divided by my y value. And you'll notice here, be careful of things like a negative over a negative becomes a positive. Same here. Negative over a negative became a positive on this one. Here, I'm dividing by a positive and it leaves those negative terms negative. Okay, so check your signs on the way through. Make sure that you were simplifying things that were negative over negative into a positive term. So why do we want to be able to do that? Well, it's going to help us kind of with our beginning graphs. Eventually, we wouldn't be using a table or this function form quite in the same way. But we're going to rewrite this equation. So 6x subtract 2y equals negative 8. So if I were to rewrite that in function form, first I'd move my x term, right? So then I'd have negative 2y equals negative 6x subtract 18. Divide everything by negative 2. And y equals 3x plus 9. Okay, so now I've rewritten this in function form. I'm going to take that and I'm going to write it as a function. So my function y of x, meaning x is my input and I'm going to get out my function y. So I'm going to rewrite it as y of x equals 3x plus 9. It's exactly the same as what's here, but I'm just writing it so it's in function notation. Okay, so here's my function y of x. And I want you to go ahead and evaluate y of x for each of these values. I'll get us started on 1. So y of 2, meaning or negative 2. If I plug negative 2 in for my input x, I would get out. So when I go y of negative 2, I get out 3. Okay. When I put in negative 2, I get out 3. And this is why it's called function form, because I plug in and I get my output. I plug in, I get my output. There's no rearranging of the equation to solve for y when I've already arranged it to be set up this way. So now I want you to go through and evaluate the following values here and then continue the video and see how you did. So I'm going to just kind of talk through these. You should have already completed. I don't have a ton of space, so I'm going to rewrite some of these. So my function y of -1, if I plug -1 in for x, then I'm going to get, oops, I'm going to get 6 out. Okay, when I plug in this, I get out that. Y of 0, if I plug in 0 for x, 3 times 0 is just 0. When I plug in 0, I get out 9. When I plug in 1, y of 1 is going to equal 3 plus 9, where my function y when x is 1 equals 12. And last, when I plug in 2, I get out 15. Okay, so here are my final answers. And again, make sure you have function notation here. And what we can do with this, where we're moving with this on our next set of notes, is I could also arrange this like a table. So if I have my function y equals 3x plus 9, we already saw if I plug in -2, I get out 3. Well, I could write that in the table, -2, 3. When I plugged in -1, I get out 6. When I plugged in 0, I get out 9. When I plugged in 1, I get out 12. When I plugged in 2, I get out 15. And there's my table showing the inputs and the outputs of this function. I put in this, I get out that. And from this table, we could also list them as ordered pairs. If you've seen ordered pairs before, where we have x and then a y value, I could list these as ordered pairs. I put in -2, I get out 3. -1, 6, 0, 9, 1, 12, 2, 15. And so this idea, that function form, makes it really easy to find a table, evaluate it in this way, where I can just put in and get my outputs pretty quickly. Okay, so today you will do some homework involving the first and second part of function notation. So just as a reminder, that last class we talked about how to determine if something is a function, that our table, every input can only have one output, that for our graphs, we can use our vertical line test, and then we talked about function notation. And today linked that function notation to being able to rewrite an equation in function form. So on your homework, if it says write in function form, you should be using your notes to help you understand what exactly that means.